Hi guys, so today we'll be talking about the Wigger's diagram. So in order to understand this, let's look at the box again, which I did in a previous video. So we have the left hand side of the heart and the right hand side of the heart. But in order to look at this diagram, we will be focusing on the left hand side. So we're going to be considering the aortic valve and the mitral valves. One important point to mention is that we will be looking at the systole phase. This is where most of the action happens. This is when the pressure is increased within the system of the left-hand side of the heart. So also let's focus on the QRS complex as well. So most of the action happens during the QRS, which is when the ventricles are depolarized, and that also means that the pressure will then increase. So let's start off with the left ventricle. So as you can see, as soon as the QRS happens, there's an increase, and then suddenly there's a little drop. And slightly after the little notch, there's an increase and there's a massive hump. And that's usually the pressure is increasing. So if the pressure is increasing, the volume within the left ventricle is also increasing. That's as the blood is rushed in, almost gets sucked in. And there are two main points on this, which I have dotted in the purple. So the first one is the mitral valve will close, which increases the pressure, and then the mitral valve will open, which decreases the pressure. So imagine like a hose. If you pinch the hose, the water behind the pinch will start increasing, which is similar to what we see here. Alternatively, let me also plot what happens in the right atrium. Not much happens. So as you can understand, if the ventricles and atria are working in opposite, so if the ventricle is increasing in pressure, the atria will decrease in pressure, as it's shown in the blue. So I've covered the ventricles, I've covered the atria. Now let's talk about the aorta, so the third and final part of this diagram. So it's plotted in this weird squiggle as I've shown now. And what happens is it's almost identical to what happens in the ventricles. So there's also a sudden point at the same time as the mitral valve closes. And this is to represent the aortic valve opening. It's the opposite. So if the mitral is closing, the aorta is opening. And if the mitral is opening, the aortic valve is closing. And another point to mention is that you also hear cardiac sound. So if you ever use a stethoscope and you can hear a lub-dub sound, the lub sound is usually at the QRS complex, which is the closing of the mitral valves. And then the dub sound is usually when the mitral valves are opening, which is the T wave, which happens after the complex. This QRS complex and the T wave is also explained in another video of mine. Just one final point to mention. So if you look at the QRS, so if you look at the black line I've drawn, so the P wave represents atrial depolarization. So that basically means there's a current within it, so it will start filling. So as you can see, when there's a P wave, there's also a hump in the blue line, which represents my left atrial pressure as well. And then when it's the QRS complex, there is ventricle depolarization, which means there's a current flowing through the ventricle. So therefore there's going to be an increase in volume in the ventricles, which is represented in the green line. And you can see whenever there's a QRS complex, there's a filling of the ventricles. And then finally, there's a little wave called the T wave, and that represents the ventricular repolarization, so the opposite of depolarization, meaning the current's almost leaving and it's relaxing, which is why you see a decrease in the pressure. Hope this quick video helped, and if you have any questions, do ask them below, and well, thank you for listening.